Hello friends, subscribers and new viewers of this channel, and welcome to Machine Learning and AI Tutorials. In this tutorial we explain how to download, install and run locally DeepSeek Janus-Pro-7B multimodal understanding model. In particular, in this video tutorial we are going to explain how to use this model to generate images. And over here you can see several examples in a single batch of generated images. And over here you can see the code that we will explain in this video tutorial. This code generates the image. Over here you can see the text prompt: a stunning princess from Italy in red, white traditional clothing, blue eyes, brown hair. And let's see the images over here again. First, second one, third one, fourth one, fifth one, sixth one, seventh one and eighth one. Here the batch is equal to 8. Now, in addition to explaining this code, I will also provide a link to this code as well as to some additional material in the description below this video. Before we start with explanations, here are some very important comments. We will install the DeepSeek Janus-Pro models on Linux Ubuntu computer. In the next video tutorial, we will explain how to perform the installation on a Windows computer. Apart from this video tutorial, we have created a tutorial on how to install and run Janus-Pro-7B for visual language understanding, which is an inverse task from the task of generating images, which is considered in this video tutorial, and link to that tutorial will be provided in the description below. Our computer has the following specifications: NVIDIA 3090 GPU, Intel i9 processor and 64 GB RAM. Now, Janus-Pro comes in 1B size and 7B size. We were able to run both models on our computer. However, for 7B size model, we had to reduce the batch size in order to be able to generate the images. We did not test the model on GPUs which are weaker in performance compared to NVIDIA 3090 GPU. Before we start with installation, it's very important to verify that you have NVIDIA CUDA toolkit and NVIDIA CUDA compilers installed on your system. Otherwise, if you don't have them, you will not be able to install PyTorch, which is necessary for running the model locally. So first of all, let's verify if you have the drivers. So open a terminal, and in a terminal type this nvcc version. NVCC is actually the compiler and the driver, and if you see this response or a similar response, this means that you have NVIDIA CUDA compiler installed on your system and you can proceed with watching this video tutorial. Note over here that the CUDA version really doesn't matter. Now, if you don't have the compiler, that is, if this command returns an error, then you need to watch this video tutorial over here on my YouTube channel that explains how to install NVIDIA CUDA toolkit and NVIDIA CUDA compilers on a Linux Ubuntu machine. I will provide a link to this tutorial in the description below this video. Next, let's start with installation. As always, the first step is to update and upgrade the packages. Consequently, let's execute these two commands, which are compressed into a single command. Enter your password, and here it is. It's not going to take a long time. The next step is to install Git. We will need Git to download, or better to say, to clone the remote repository of Janus. Next, make sure that you go to the home folder. And in this home folder, we are going to clone the remote repository. The remote repository of Janus is located over here. Note that this repository also contains partial instructions for installing the model. Namely, after you download everything, you need to do several things. One of the things is to run this installation command. However, a lot of things are not actually explained on this website. For example, how to clone What are additional things that you need to do? For example, you will also need to download the model files over here, and I'm going to explain that later on. For the time being, make sure that you copy this address, then go back to the command prompt or terminal and simply type git clone, and then you need to specify the address. And here it is. Now you have downloaded the remote repository. And if you type ls-la, you will see in your home folder Janus folder. Consequently, let's go to the Janus folder. And here we are. Let's verify the files are here. They are here. Perfect. In this video tutorial, we are going to test two models. The smaller model having 1 billion parameters and the larger model having around 7 billion parameters. Consequently, let's create two folders. The first folder for the first model and the second folder for the second model. The next step is to create a Python virtual environment. First of all, let's make sure that the command for installing the Python virtual environment is installed. But before we do that, let's verify that we have Python on our system. To do that, we can first of all type this, and over here you can see as the response the path to the Python executable folder. Now, let's check the Python version. And over here you can see that I'm using Python 3.12. The command for installing virtual environment, that is the command for installing the command for virtual environment, is given over here. Over here you need to adjust the Python version and press enter. Next, let's create Python virtual environment. And let's activate the Python virtual environment. Here it is. We are currently in the Python virtual environment and we need to install the Hugging Face Hub library. We need this library in order to download the remote models. So type this. And let's make sure that the library is installed. In fact, this library contains a number of packages. Okay, the next step is to write a Python code that will download the remote repositories. So let's learn how to do that. Well, first of all, we have to see where are the model files. If you go to this website, you can see where the model files are. That is the Hugging Face links. So let's click over here and let's click over here. The first link is the web page of the smaller model, Janus-Pro-1B. And the second page is the web page of Janus-Pro-7B. We will need these two addresses, that is this address and this address. Let's write the code. Open your favorite Python editor. In my case, it is Visual Studio Code. I created several video tutorials on how to install Visual Studio Code on Linux Ubuntu. Links to these tutorials will be provided in the description below. However, as I said, you don't need to use Visual Studio Code. You can use any Python editor you like. So click on File, New File, and let's call the file download.py. Here it is. Save it in this workspace folder, and let's quickly write the code. Here I will simply copy the content of the code and I will paste it over here. And let's adjust what needs to be adjusted. First of all, let's go to the web page of the first model, copy here, then go back to Python editor and paste the command over here. Let me just select this and Control V. And the next thing is to specify the path of the directory of the first model. Okay, so let's go to model 1 we just created and type this. And you can see the path. Copy this path and paste it over here. And here it is. Okay, save this file and next we need to run it. To run this file, you need to tell to Visual Studio Code that you want to use the Python interpreter from the Python virtual environment. To do that, press and hold Ctrl-Shift-P, then search Python, select interpreter, then select this interpreter inside of our virtual environment, and then click over here and the magic will happen. Now the model will be downloaded from the remote Hugging Face repository. And you can see what you're downloading. You're downloading several files. The larger files are these two files. They're around 10 gigabytes in total. Okay, once we do that, we are going to adjust over here. That is, we are going to download the second model. Next, we need to download the second model. Consequently, over here, let's make the adjustments. The folder should be model 2. And over here, the name of the model, let's double check, is given over here. So let's copy this thing and let's paste over here. So the model from Hugging Face will be stored in the folder model 2. Let's save this and let's run again. And again, you can see that the model is being downloaded. Note over here that we are downloading 15 gigabyte of model files. Consequently, you need to be patient. Next, let's verify that the models are successfully downloaded. Let's go back to the command prompt, and currently we are in the model 1 folder. We should see everything over here. What is very important to see these huge files which represent the model. Next, let's go to the folder model 2 and then list over here all the files. You can see these huge files representing the weights, and we can continue further. Next, go to the base folder, and inside of this base folder, you need to run this installation command. However, before you run this installation command, do yourself a favor and try to investigate what this command is actually doing. Now I'm going to the home folder, then I'll go to Janus, and then over here you will see this file requirements.txt. And what this command over here will do, it's going to install the required libraries over here. You can see the Torch version, Transformers version, this library, Accelerate, Sentence-Piece, Atterdict, as well as other things. Good. So let's run this command to install everything, and let's cross our fingers and let's hope that everything will work well. Okay, now everything is being downloaded. Packages are being installed as well as the libraries, and everything's being built. So be patient. And after the packages are installed, let's type pip list to make sure that we have all the packages. We can see Pillow, we can see NVIDIA, these packages, we can see PyTorch, Accelerate, etc. Good. The next step is to write the code that will generate images. Again, go back to the Visual Studio Code. That is, click on File, click on New File, and let's call the file as test.py and create file. And over here, to save time and energy, I'm simply going to paste the content of the file. So here is the file I wrote. I will copy it, I will go here, and I will paste it. Okay. So I will also provide the link to this file in the description below this video tutorial. So let me briefly explain what's happening over here. Here you need to import the necessary libraries. And here's the first modification I created compared to the file given on the GitHub webpage. Namely, if you go to the DeepSeek GitHub webpage, you will go down, 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 and over here, yes, over here, you will see this file for text to image generation. I started from this file and then I made several modifications. And here's the first one. Here, I'm making sure that CUDA doesn't, or better to say my GPU doesn't run out of memory. Then over here we need to specify the model path. If we want to use the first model, let's type this path over here. Let me explain what this path is. Now, if you go to model 1 and if you type pwd, you will get the absolute path. Consequently, copy this path and paste the path over here. And here it is. Save also the file. Over here, we load the model. From this path, we define the tokenizer. Then we called automodel for casual LM. Then from pre-train, we specify the model path, we specify this option true, then we create VLGPT, and here comes the main part. Over here, we can ask the question. So let's ask a question: a stunning princess from Italy in red, white, traditional clothing, blue eyes, brown hair. That is, this is the description of the image that we want to generate. Over here, we specify a role, we specify SFT format, we use the VLChat processor. Then you can see other parameters over here, and then over here we define the generate function, and in this generate function you have several things that you can modify. First of all, over here I'm going to decrease this parameter, parallel size. Parallel size actually tells you how many images do you want to generate at the same time. I will go with 8 images. Why do we generate more images? Well, some images might contain some artifacts or hallucinations, and consequently you need to generate not a single image but several images and to choose the best image. Then over here, don't play with these parameters, don't play with the image size and patch size, leave them by default. Then over here we are defining several objects. Then inside of this function there are several things that are happening which are not important to understand at this time being. Let me just show you furthermore. So if you want to type, I'm not sure that anyone will type. However, if you want to type, you can see what's happening over here. Again, the file will be provided in the link that will be given in description below. That's it, nothing special. And over here, we are simply again emptying the cache, and this is another modification I made compared to the file given online. And over here we generate. That's it. Simple as that. Save the file, do Ctrl-Shift-P, search for Python select interpreter, make sure that you use the default interpreter, and let's run. But before we run the file, let's first discover where are the stored files. Namely, somewhere in this folder over here, that is in the workspace folder, you will see the stored file. So where are they? You need to find them. If you go to the line 89, you will see this os-make directory command. This command will create directory generated samples, and over here you can see the file format of the saved files. You can see how the files are being saved. Okay, so that's it. So once we run the code, a new folder will be created in our workspace folder whose name is generated sample. And let's run this code and let's hope that everything will work as expected. Okay, so this is a smaller model, and so let's see the speed of the model. Now I can already hear my GPU running in the background, and that's it. Good. Let's see the generated images, where they are. Let me refresh. And here they are. Okay, first image, doesn't look bad. Second one, third one, fourth one, fifth one, sixth one, etc. Among these images, there may be only several images. For example, this one, let me try to enlarge this. This is basically very low resolution. Not very low, the image size is small. Maybe this one, I can see that the eyes are not clear. Maybe this one, maybe, and several others. Okay, so that was the first model. Let's test the second model. To test the second model, again, you will go here. And then you will modify two things. You will just change the model name, and that's it. Now, to see the difference, I'm going to simply copy, or let me cut everything, and let me create a new folder called test1. Let me save the files here. Now over here in this generate sample folder, we will not have anything, such that we can see the second batch of images. We don't want to overwrite the images, that's why we are doing that. So let's save this, let's run it, and let's see what happens. Now the second model is being loaded, and you can see over here it's going to be a little bit more longer. You can see what we are loading over here, and then let's wait. Now what I noticed on my GPU, if I keep this parallel parameter where it is, let me show you. Let me just go down and show you where the parallel parameter, here it is. Parallel size, if I keep it as a default value, that is at 16, you will see that CUDA will run out of the memory. That's why I decreased this parameter. And let's see the files. Images, here they are. Okay, this looks better, honestly. Although eyes are still a little bit not clear, but looks better in my opinion. Again, you can see a bunch of artifacts. However, this is the issue that we have to live. Okay, so here is my honest opinion. I think that this model is still behind Flux1 Dev. Namely, Flux1 Dev gives much clearer and better images compared to this model. However, I believe that DeepSeek Janus-Pro model will improve in the future, and they're just starting and trying to catch up with Flux1 Dev and with other text to image generating models. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.